Okay, so today we'll be starting chapter 13, surface area and volumes. Now, class 9, you have already done quite a bit of surface area and volume, so this is going to be quite easy. But for revision's sake, let me just go through all the formulas that are essential for this chapter. The 6 figures that you've done in class 9, cubes, cuboid, sphere, hemisphere, cylinder and cone is there. And in class 10, there is frustum of cone, although they have deleted that part. So I'm revising with you the formulas once again, because this is important that we know the formulas before we proceed to the questions. So first of all, we have to understand what a cube is. A cube is a figure in which all sides are equal. So this is the side of the cube. And we talk about two areas, right? Lateral surface area, which is represented by LSA. So that is the four walls. Okay, you want to paint the four walls of a cube, and that is lateral surface area. This will be, there will be four sides. So this is going to be four side square. So the formula that we are going to apply here for lateral surface area will be 4 into side square. Side square is the area of one square. And like this, the lateral surface area means the four walls. And if the box is closed from all the sides, so all the 6 sides are closed, then we use the formula 6 side square. So this is called the TSA, which is called the total surface area. The volume of a cube can be found by using the formula side cube, okay, side cube. And diagonal of a cube can be found by using the formula root 3 side. Diagonal of a cube is root 3 side, okay. So if I want to find the diagonal, that is the longest possible rod that can be placed in a room, which is cuboidal or cube, then diagonal has to be used. So in this case, it is cube. So diagonal of a cube is root 3 into side. Next, we come to cuboids. And in cuboids, we have 3 dimensions, the length, breadth, and height, okay, represented by L, B, and H, length, breadth, and height. If I want to find the lateral surface area, that is the area of the four walls, I will use the formula 2H bracket L plus B. Okay, that's lateral surface area. Total surface area will be twice of LB plus BH plus HL. And the volume is going to be LBH. Okay, so LBH is the volume. And diagonal similarly of a cuboid can be found by using the formula root of L square plus B square plus H square. So I can find the diagonal by using this formula root L square plus B square plus H square. So these are the two formulas, two figures. One is cube, 4 formulas, cuboid, 4 formulas. After this cube and cuboid, the next thing that we go is cylinders and cones. Okay, cylinder and cone. So cylinder can be open at the two ends. So we have the radius and we have the height. So the lateral surface area is also called the curved surface area, because unlike cubes and cuboids, this is curved, right? So it is called CSA, curved surface area. This is 2 pi RH. And the total surface area can be found by using the formula 2 pi R plus H. This is the TSA. And volume of a cylinder can be found by using the formula pi R square H. And here there is no additional formula here. It can be closed, open, and the volume. And then we come to the fourth figure, that is cones. Cones. So cone can be opened at this end, like an ice cream cone or a joker's cap, or this is open. Then we use the curved surface area, that is pi r L. Now L is slant height of a cone. Now unlike the height of a cylinder, here we have two heights. One is the normal height, that is H, and this is called the slant height. So slant height is this distance from A to B. And the distance from O to B is your perpendicular to OA, that is the radius, that is the height. So curved surface area can be found by using pi RL. Total surface area is pi R plus L. And volume is 1/3 of what happens in cylinder. Cylinder is pi R square H, cone is 1/3 pi R square H. And using Pythagoras, I can easily find out slant height. In some questions, slant height is not given. So I can find L by using L square equal to H square plus R square. So these are the formulas for cylinder and cones. After this, next we come to spheres and hemispheres. So We have sphere. Sphere is like an earth. Earth is spherical. It's three-dimensional, not the circle as it is seen in the screen, but it is like a football, okay, covered from all sides. So here we don't have curved surface and total surface. We have only one area, okay, that is the surface area. So that is 4 pi r square. This is the radius of the sphere, and volume can be found by using 4 by 3 pi r cube. So volume and area. And if I cut this sphere into two parts, I'm going to get half of a sphere, which is called the hemisphere. So the hemisphere can be open or closed. Hemisphere can be open or closed. At the moment it is open. So I can use curved surface area will be 2 pi r square. And if it is closed, then I have to add pi r square more. So 2 pi r square plus pi r square, we will get 3 pi r square. And volume can be found by using 2 by 3 pi r cube. So this is 4 by 3 pi r cube. This is half of that, 2 by 3 pi r cube. So these are the 6 figures that we have to do. Of course, frustum of cone was there, but the third exercise stands cancelled. So I'm not discussing the formulas for those. So the frustum of cone formulas, besides that, the 6 figures which you've done in class 9 is now going to be repeated in class 10. So we are going to straight away go to the questions. So this is our chapter 13. So let me go to the first exercise. Okay, so there we come to the first exercise 13.1. You can see on your screen, two cubes are joined end to end, and the volume of one cube is 64. Find the surface area of the resulting cuboid. So what is happening is you are having a cube and you are joining another cube with that, and we have to find out the resulting cuboid. So volume of one cube is given 64. Side can be found because volume of a cube is side cube. So volume is given 64. So 64 is side cube. So what is the side? Side will be cube root of 64. And what is cube root of 64? That is 4, right? So once we get the side, now we know that two cubes are joined end to end. So this is 4, this will also be 4. So the total length of the cuboid is going to be 4 plus 4, that is 8. And what happens to the breadth? Nothing happens to the breadth, that will remain same, 4. And height will also remain 4. So when two cubes are joined, only the length is going to increase and length will become 8. Breadth and height are going to remain 4 itself. So now the question is find the area of the resulting cuboid. So when we are finding the area, we are going to use the total surface area of the cuboid, that is 2LB plus BH plus HL. Now please remember, for cubes and cuboids, if only area is mentioned, you don't know whether it is closed or open, you will assume that it is closed from the ends. You will assume it is closed for cubes and cuboids. For cylinders and cones, you will assume that it is open unless it is mentioned, of course, in the question. So here there is nothing mentioned, so it is closed. For cubes and cuboids, please note this, cubes and cuboids will be considered closed if not specified, and cylinder and cones and hemispheres are going to be considered open if it is not specified what is the status of the figure, right? So here we are going to assume it is closed. So I'm applying 2LB plus BH plus HL. So 2 into L into B. So L into B means the length is 8. So 8 into 4 gives you 32. Then breadth and height both are 4. 4 into 4 will give you 16. Then length into height. Length is 8. 8 into 4 again 32. 32 plus 32 64 plus 16 80. 80 into 2 we get 160. So your first answer is 160 centimeter square. Okay, so that's clear, I suppose. The second question, a vessel is in the form of a hollow hemisphere mounted by a hollow cylinder. So the question 2, let me just delete this and scroll down the screen so that there is better visibility of the second question. So here I am going to scroll down further so that you can see the question properly. So what is the question here? A vessel is in the form of a hollow hemisphere. Okay, this is a hemisphere mounted by a cylinder. Mounted means cylinder is on top of the hemisphere. Mounted by a cylinder. Mounted by. The diameter is 14, so radius is going to be 7. Total height of the vessel is 13. Question is find the inner area of the vessel. Inner area of the vessel, this is a combined figure. And as I told you, it is given that it is hollow. Hollow means it's open. Open means we'll have to use curved surface area for the two. So 2 pi r square for hemisphere and 2 pi r h for the cylinder. Now the most important thing to understand in this is that the total height here is 13. The radius is 7. So the radius is 7 means what is going to be the height of the cylinder? The height of the cylinder is going to be 13 minus 7, that is 6. This is very crucial here because 13 is the distance from this point A to this point B. And remember, the radius and height of hemisphere are always equal. So radius is 7. So the height is also 7. So these two are equal. So this part is going to be 13 minus 7, 6. Now the area 2 pi r square plus 2 pi r h. What is common here is 2 pi r. So what do we get? R plus h. So 2 into 22 by 7, radius is 7. 7 plus what h? H is the height of the cylinder, which we have calculated as 6. So 7 is going to get cancelled here. We get 44 into 13. So we get the area is 572. So that's answer number 2, 572 centimeters square. Okay, moving forward, we go to question number 3. Question number 3 is somewhat similar. A toy is in the form of a cone. This is a cone mounted on a hemisphere. Now, instead of cylinder, this is a cone mounted on a hemisphere. Below is a hemisphere, on top it's a cone. So radius is given 3.5. Height is again 15.5. So the total height from here to here is 15.5. So just like we calculated the previous one, the radius here is 3.5. So the height of the hemisphere is also 3.5. So from 15.5, you will subtract 15.5. You are going to get the height of this conical portion as 12. Now the question is find the total area of the toy. Now they are asking you total area of the toy. This is a combined figure. Please remember, in combined figures, you will always find out the curved surface area, not the total surface area. So don't get misled by this word total surface area. Don't use total surface area of this and total surface, because this part which is inside, you don't have to break and calculate and see what is inside. This is a figure and you have to find only the area which is visible to you. So that is the curved surface area. So 2 pi r square and 1 by 3 pi r square h. I'm going to add this. So to find the area of a cone, we know that the formula is 1 by 3 pi r square h. So for the cylinder, and that is for volume, and for area, we'll have to use formula pi r L. So if it was volume 1 by 3 pi r square h, this would have been easily solved because the height is there and radius is there. But when we are finding area, the formula is pi r L for curved surface, and I don't know L, so I will have to calculate L by using the formula L square equal to h square plus r square. So height we have calculated 12, so 12 square plus 3.5 square. So this is going to be 144 plus 12.25. So this is going to be 156.25. So square root of 156.25 will be 12.5. So I can say that the slant height is going to be 12.5. Okay, so this is important that we calculate the slant height. Now, once we calculate the slant height, what is the formula to find the total area? It's going to be 2 pi r square plus pi r L. So we can take out pi r common. So we get 2r plus L inside the bracket. Now we have pi as 22 by 7, radius is 3.5, 2 into 3.5, and slant height we have calculated 12.5. You can substitute these values and you will be able to find out the area. Okay, so we are going to calculate this. I am sure you will be able to calculate this and get the answer. For verification purpose, I just scroll down the screen. You will be able to check this. So I'm going to go down here. Yeah, so this is the formula I told you. So substitute. And here the 7 is getting cancelled. 2 goes 11 times 11 into 19.5, 214.5 is your final answer. Moving on to question number 4. You can mark this important, slightly complicated figure, but nothing to worry. This is a cubical box surmounted by a hemisphere. So cube is there and this hemisphere is surmounted on top of this, right? And the question is, what is the greatest diameter the hemisphere can have? That is easy because this is 7. The size of the side of the cube is 7. So diameter will be 7. It cannot be greater than 7 because then the hemisphere will extend outside the cubical block. So the greatest possible diameter is 7. So that's pretty clear. Now comes the next part, find the surface area of the solid. Now to find the surface area of the solid, what will we do? We are going to calculate the area that is visible to us. And what is the area that is visible to us? Please note down carefully. See, this is our cube. And if you look at the cube, this was surmounted by the hemisphere. So 5 sides are free. There is nothing on the 5 sides. So our formula will be 5 into side square. That is the 5 sides of the cube. Plus, if you look at the 6th side, what is happening on the 6th side is the square is there, but it is being blocked by the base of the hemisphere. This is getting blocked. So this is not visible to us. So what is visible is only the protrusion of the hemisphere on top. So on the 6th side, the formula of the remaining portion will be side square minus the circle is blocking this. So you are left with only these ends, right? So what is happening is that the circle is blocking. You are left with these corners only. So how do you find the area of these corners that are visible here? It is going to be the square minus the circle, side square minus pi r square. Plus, what is the area of the hemisphere? The curved surface is visible, so that is 2 pi r square. So when I'm going to solve this, I'm going to get 6 side square plus 2 pi r square minus pi r square. I'll get pi r square, right? So this is going to be the formula that I will get 6 side square plus pi r square. Now 6 into what is the side of the cube? It is given to me 7 plus 22 by 7 into radius. Just now we said that the diameter is also 7. Okay, because it's touching from one end to the other. So radius is going to be 7 upon 2. So I'm going to cancel here. This is going to be 6 into 49 plus 77 upon 2. So we'll calculate this. 9 6 are 54 and 6 was 24 and 29 here plus 38.5. So 294 and 38.5. When we add this, we are going to get 332.5 centimeter square, which is going to be the area of this figure. So I hope you understood this. If you understand, it's easy. The 5 sides were free. The 6th side, the circle is blocking the 6th side. So the area, required area, the corners will be the side square minus pi r square plus the hemispherical part, which you see here, is 2 pi r square. So when you add the like term 6 side square plus this and this, when we add, we get pi r square. Then it's after all a matter of calculation, and you get the required answer 332.5. Question number 5, hemispherical depression. It's the reverse. Okay, now what, instead of the hemisphere coming on top, now it's a hemispherical depression coming here. So hemispherical depression, and then again the diameter is given L. The diameter is L, that means the side of the cube will also be L. Again, question is find the area of the remaining solid. So it's very identical to this. So what is happening in, like in Diwali, you must have seen candles which are cubical, and then there is a hemispherical depression where the wick is there and the wax burns, right? You must have seen like this. So what is the area? Now the logic that we'll apply is same as what we did in the previous sum. That is, the 5 sides are free. So I'm going to use 5 side square plus, if you look at the 6th side, again, this part is empty. Earlier, this was blocked because the hemisphere was on top of this and it was blocked. Now, instead of blocking, what is happening? There is a pit. Okay, there is a hemispherical pit. There is air. Nothing is there inside. So only if you're looking at a wax or something like that, whatever material is there, that is going to be at the corners which are left. So how do you find that? Same, side square minus pi r square. Because from the square, we'll have to subtract the circular part. Plus, what is going to happen? The hemisphere is there. Just like the hemisphere was on top in the previous question, now the hemisphere is there. So suppose you have to paint this figure. Always think in terms of painting. What are you going to paint? The 5 sides will be painted. Plus on the top, you have these corners to be painted. That is this. Plus you'll have to also paint the inside. You'll have to do the painting inside. So what is the curved surface there? That is 2 pi r square. So again, this is going to be 6 side square. And if I solve this, I'm going to get pi r square. So it is given to you diameter is L. So if the diameter is going to be L, the side of the cube will also be L. So this will be 6 times L square plus 5 into, if the diameter is L, radius is going to be L by 2. So what do we get? 6L square plus 5L square by 4. You can take the LCM. This will be 24L square plus 5L square. I can take L square common. So I'll get 24 plus 5 upon 4. So this is going to be the required area here, L square by 4, 24 plus 5. Okay. So we can easily get the answer here. The questions of the fourth and fifth are more or less related. The technique is same, only the in one it's a depression and in one it is surmounted. So that is the difference. But the formula, if you see, the technique is identical. There, of course, dimensions are given. Here, without dimensions, you are getting the answer in terms of L. Right. So we go to the next question, number 6. A medicine capsule is in the form of a cylinder here with two hemispheres. Okay, we have two hemispheres here, and it's easy if we demarcate these hemispherical portions. Okay, so this is actually cylinder from here to here. Okay, this is a cylinder here, and the two ends are hemispherical, and the total height from here to here is 14. So if this is 14, see here, this portion is 5. That is the diameter of this is 5. So radius is going to be 2.5, isn't it? So this part is 2.5. This part is also 2.5. So 2.5 here and 2.5 here. So if the radius is 2.5, I will subtract 2.5, 2.5. That is 5 from 14. Then I will get the length from here to here, which is actually the height of the cylinder. So height of the cylinder will not be 14. It will be 14 minus 5. Why 5? Because 2.5 on either side has to be subtracted. So I'm going to take the height as 9. Okay, so it's important that you calculate the height of the cylinder. Now we have to find the area. So it's a combined figure. We will calculate curved surface area of the two hemispheres. So 2 into 2 pi r square. This is the area of one hemisphere. So multiplied by 2. So we get 2 into 2 pi r square plus what is the cylinder? 2 pi r h. So your formula will be 4 pi r square plus 2 pi r h. And now what will happen? You're going to take common. What is common here? 2 pi r. So what is left here is 2r plus h. So we'll get 2 pi r, 2r plus h. Now substitute 2 into 22 by 7. What is the radius? Radius is 2.5 you can take, or 5 by 2. Okay, diameter is 5. So radius is 5 by 2. And inside the bracket you will get 2 times r. So 2 into 2.5 or 2 into 5 by 2, that's 5. Plus the height we have just now calculated, 9. Okay, so when you calculate this, 9 and 5, 14. 14 and 7 to the 14 will get cancelled. So what are we going to be left with? This will be 22 into 5 into 2. 2 into 22 will be 44. 44 into 5. You are going to get 220. And the unit is going to be millimeter square. Right, so we are applying the direct formulas, and the formula is very important, and since you have done in class 9, I think it should be easy. If you have forgotten, it's important that you revise the formulas. Okay, we move on to the next question, that is question number 7. A tent is in the form of a cylinder. Okay, this is a cylinder. It is surmounted by a cone. It is surmounted by a cone. The height is given 2.1, height of the cylinder, and the diameter is given 4. If the diameter is 4, then the radius obviously will be 2. Find the area of the canvas used to make the tent and the cost at the rate of 500 rupees per meter square. So first thing that we do is find out the area of the two, which areas? Lateral surface area. Combined figure always lateral surface area. So 2 pi RH plus pi RL. So in this, pi r will be taken common. You will get 2h plus L. Okay, slant height is given to you, so nothing much to do here. Slant height is also given 2.8. Direct substitution, 22 by 7 into radius is 2. So 2 into height is given 2.1 and slant height is given 2.8. So this is going to be 4.2 plus 2.8. that is going to be, we'll add this 4.2 and this is going to be 22 into 2 into 7. So 7 and 7 gets cancelled and we are going to get 44. So this is the calculation here. This is 4.2 and 2.8. You will get 7.0 here. So this is 7, this whole bracket when I solve, this 7 and 7 I am going to get cancelled. So 2 into 22, 44. Now once you get the area as 44, the cost is area into rate. So what will I do? I will multiply the area obtained with 500. So I'm going to get the cost as 22,000 rupees. Right, then question number 8. From a solid cylinder whose height is 2.4, this height is 2.4, diameter is 1.4, so radius will be 0.7. A conical cavity of the same height and diameter is removed. So you are removing this. Okay, find the total surface area of the remaining solid. So what is happening? Initially, you had a cylinder, and then what is happening? You are removing the conical portion. You are removing this. So when you remove this, what is going to happen? You are left with a figure like this. Okay, because this part you have removed. This part is removed. So when you're removing it, what is this? This is what is left. So question is, what is the area of this? So what are the figures? Suppose you have to paint it. I always talk in terms of painting because that's the easiest way to identify what has to be calculated. So you have to paint the outer surface area here, that is 2 pi RH for cylinder. You have to paint the base here, that is a circle, that is pi r square. And you have to paint the inside of this, so that is going to be pi RL, all curved surface areas. Okay, so I'm calculating curved surface area. Okay, this is pi r square. Okay, because this is given it's solid. If it is solid, that means this base is covered. This, of course, you have scooped out, and therefore, if this is scooped out, you are left with only this portion, that is a conical part, curved surface pi RL. So you can take pi r common here. So we will be left with 2h plus r plus L. So this is going to be the result, and you just have to substitute now the values. Of course, here L is not given. So L square equal to h square plus r square. Height is 22.4, so 2.4 square plus radius is 0.7. So 2.4 square plus 0.7 square, we get 5.76 plus 0.49, that is 6.25. Root of 6.25, we get 2.5. So slant height is 2.5. Now we have all the values with us. So radius is 0.7. I can put that 22 by 7 into 0.7, twice of the height. Now what was the height? The height was given 2.4. 2.4 plus radius 0.7 plus slant height we just now calculated. No, L square is h square plus r square. So we've got 2.5. So this can be cancelled 0.1 times 22 into 0.1 will be 2.2. This is going to be 4.8 plus, I'm going to add this, I'm going to get 3.2, right? So this is 2.2 plus, I'm going to add this, I'll get 8 into 8. So 8 to the 16, 6, 1, 8. So I'm going to get 17.6. And what is the unit here? Centimeter square. And the question also says that round off to the nearest centimeter square. So 17.6 centimeter square. How do we round it off? If it is 0.5 or more than 5, what will happen? It will be rounded off to the next higher number. So final answer 17.6 will be rounded off to 18 centimeter square. If it was 17.4, 17.3, then it would have become 17. So rounding off, I'm sure you know, if it is 0.5 or more than 0.5, it goes and rounded off, gets rounded off to the next. Okay, so we are almost at the end of the exercise. That's question number 9 for you. This is a wooden article made by scooping out hemispheres from each end. So both ends, the hemispheres are scooped out, right? It's like this, the ends here also scooped out, here also scooped out. Height of the cylinder is given 10, radius is 3.1, the area of the article. So area of the article, first you have to find 2 pi RH, that is the curved surface area, and then from top, this is hemisphere, that is 2 pi r square, and here also is you have scooped out a hemisphere, that is also 2 pi r square. So you are painting which surface? You are painting the outer surface area, curved surface area of cylinder plus the two surfaces of the hemisphere which are open, right? So 2 pi r square here and 2 pi r square here. So 4 pi r square plus 2 pi r h. That will be the final equation. 4 pi r square plus 2 pi r h. So what is happening here? We can take 2 pi r common, and if 2 pi r is common, you are left with 2 r plus h. So 2 into 22 by 7, radius is 3.5, already given to us. And inside we have 2r, so 2 into 3.5 is 7, plus height is already given 10. So this becomes 17. 7 and 3.5, I'll cancel 0.5. This is 44 into 0.5, 44 into 0.5 is 22, 22, and this bracket is 17. 22 into 17, you will get 374. Okay. So that's the end of the exercise, I believe. Yeah. Okay, so 30, you can note down this much. Yeah. So 374, that will be our final result. So 374 centimeter square.